Hello, I'm Collin Daigle. Today I'm going to be showing how to set up an AC circuit in Multisim. First thing you want to do is place an AC source, and then we are going to add some resistors. Add a 2000 ohm resistor and a 1.5 thousand ohm resistor. Now obviously this isn't a circuit, this is just components, so to complete this, we're going to need a ground. And finally, I have to connect everything up. Oh, let's see. Let's rotate this. Now to make this easier to look at, we're going to turn the net color of the bottom wire to black. And there we go. This is a simple AC circuit. So we have our circuit, we have our objective set. Now we need to have some way to measure this. And this is done with an oscilloscope, which is right here. This is a 2-channel oscilloscope, which means it can measure 2 different voltage and sources at once. So we're going to connect channel A to the source, so positive, negative. And channel B, we're going to be measuring around resistor 2. Let's see. To make this a little less confusing, we're going to turn this segment color blue and this one green. And then we're going to turn this one orange. And then this one purple. So now we know our lines are clearly marked. And obviously nothing's going to pop up now because we have to run the circuit. And then once we run the circuit, we start collecting data. We can stop it. And then to get a more accurate picture, we can change the scale of the x-axis and the scale of the y-axis. Now to get started on our objectives, we're going to measure voltage peak to peak, and that is done by using these little sliders. So you slide it to the top, and then to one peak, and then to the next peak. And that gives us a rough estimate, but we want to be exact. So we're going to get these to snap by right-clicking them. Go to next Y max. Go to next Y min. And that gives us a VPP of 6.778 volts. 6.778 volts. And VRMS is done by a formula, and that formula is, I'll write it down here. It is voltage peak equals, or VRMS equals voltage peak times 0.707. Now to find our voltage peak, we just take this, bring this to about 0. So what we're going to do is go to the next set X value. We're going to do 0. Whoops, that is not what we wanted. See, we're going to set the Y value this way to 0. There we go. That puts it at 0. So our VP is 3.389 volts. So let's edit this. So we have 3.389 volts. Now if we do some quick maths here, do 3.389 times 0.707, and that gives us a VRMS of about 2.39, 2.4. So we'll just say 2.396. 2.396 VRMS. Now the period is the spacing between each peak. So that is or between each cycle. So that is between the peak here and the peak here. That is one cycle. Or you can measure it from the up crossing going up from here to crossing going up from here, or down to down. It doesn't really matter. So what we're going to do is get this, and we're going to go to set y value this way of 0. And then we're going to get this one, go to the next y value of 0. And then the space in between here is going to be our period. Let's see. That gives us a period of 1 millisecond. So we have 1 millisecond, or 0.001 second. And the frequency is just the inverse of this. So let's see. Whoop. Frequency equals the inverse of period. So that would be 1 divided by t, which is 0.001, and we want to keep this in the base. So we'll just do some math again. 1 divided by 0.001. Our frequency is 1000. And that is in hertz. All right, now to move on to our second channel, or B, across resistor R2. Now to do this, we're going to bring this back. We're going to zero out channel 1 just so we don't see it. And to make this a little easier to see, we're going to lower the division a bit. All right, that's a little better. And it's the same thing essentially. So voltage peak to peak, next Y max, next, whoops. I'll do this one to the next Y max. And then channel B, voltage peak to peak is 3.873 volts. 3.873 voltage peak to peak. Then VRMS, it's the same thing. It's VRMS equals VP times 0.707. So let's see, we're going to keep that on the peak. And then we're going to move this to the next Y value of 0. And our voltage peak is 1.973. So let's see, 1.973. Let's do some math. 1.973 times 0.707. And then times 0.707 gives us a VRMS of 1.394. So we'll just say 1.395. 1.395 VRMS. And the period, it's the same method as last time. Let's go from the 0 right here. So 0. Then we're going to go to the 0 right here. 0. And that gives us, obviously we're going to use absolute value here, but if you switch these around, it would be positive 1 millisecond. So that gives us 1 millisecond. And the formula is going to be exactly the same. 1 divided by 0.001. And that's going to give us a frequency of 1000 hertz.
So we're going to build a small 2 resistor circuit, and our first resistor is a 1.5 kilo ohm resistor, and the color code for that is brown, green, red. So we check this one, brown, green, red. That's correct. So we're going to put it positive terminal, connect it to column 30. Oops, not 30 because that one's blocked. 29. And then our second resistor is a 2 kilo ohm resistor, which is red, black, red as the bands. Connect that to the same column so it continues to carry the current, and then connect it to the negative terminal. And then we're going to take our lead wires just so we don't have to connect all the clips to the resistors. The positive terminal, and our black wire to represent negative goes in the negative terminal. Put it on, give it a twist to the clockwise direction, and it's on. So here, actually, you can see right there. Yeah, sure. Measure voltage, scroll down to the RMS, and we can look at the period also, and we can do also voltage peak to peak, voltage peak right there, and what else do we need? Frequency. Right there. Each block is worth 1 volt, so we count up 1, 2, 3, 4, and that gives us a voltage of 4 from peak to peak.